All right. Oops, let me unfreeze the screen here. Today we are, there we go, unfrozen. Looking at solving rational equations. Okay, so what we were doing before is we just had rational expressions and we were simplifying. Now what's happening is it's almost the same thing, except now it's equal to some other value and we have to figure out what the variable, the unknown variable, represents. Okay. So again, the only thing that's different is we now are equal. One of the easier ways to solve these are, it's very similar to method 2 that we did on simplifying the complex. If you multiply both sides of your equation by the least common denominator of the whole equation, what happens is you will eliminate all the denominators. So that tends to be the easier way. Of course, it just kind of depends on the problem. This first one, I'm also going to solve the left side first and then set it equal to, which turns into just a cross multiplication problem. Always keep in mind the domain from the beginning. Okay, so when you work these out and you get your solution, always go back and check, because depending on the variables, right, we often have them in the denominator. So again, like this first one, what do we already know y cannot be?
0.
Okay, we know it can't be 0. So those are things you always want to check and make sure that it still works out. All right, so let's go ahead and start with the first one. I have 10 over 3y minus 5y is equal to 1/4. All right, so again, similar to method 2 of the simplifying, I want to find the least common. Yes?
Can you go up a little?
You can just scroll back.
Yeah, just
Okay. I'm going to find the least common multiple of all the denominators on both sides.
4 also?
Yes, including the 4. All right, so coming over here, I have one denominator is 3y, one denominator is 2y, and one denominator is 4. So the least common denominator for all three of those would be what?
12y.
12y. And so we're going to multiply that 12y to both sides of the equation. Right? So on the left side, I'm going to put parentheses around here and show that we're multiplying by 12y, and we're also going to do that to the right side. So I'm going to write this first step out completely, just so that we can see why the denominator goes away. So in the first one, distributing through, I have 12y times 10 divided by 3y. All right, so I don't want to do 12 times 10 is 120. 120 divided by 3 is 40, right? We want to keep things small. Yes?
Oh, I was just going to say, so you could like cancel out the y's. And
Exactly.
Then, turn the 12 into a 4.
Yes, exactly. And that's the whole point of doing it using this method, is your whatever denominator you have, it should divide evenly into the numerator, or not the numerator, into the term that you multiplied in to simplify. Yes, Jocelyn?
So can you just divide the LCMs by the denominator and then multiply the answer by the numerator, and that's it?
Multiply, I'm sorry, I didn't quite
like
catch that.
Divide the LCM by the denominator and then take that answer and multiply it by the numerator?
Yes,
Okay.
yeah, that's essentially what we're going to do. And that's why I'm writing this step out. Okay, so like you said, these y's divide out, and 3 goes into 12 4 times, and we're left over with just 4 times 10, which is 40. Okay. And I'm going to do the same thing for the next one. Be careful when you have a subtraction. Okay, so again, I have 12y times 5 all over 2y. Right, it's the same thing. If you've used the least common denominator, your denominator should divide evenly into the term that you multiplied in, right? So the y's again will divide out. 2 goes into 12 6 times, and we're left over with 6 times 5, which is 30. So 40 minus 30 equal to, and the last one, 12 times 1 is, or sorry, 12y times 1 over 4. And again, 4 goes evenly into 3, and we're left with 3y on the right side. So now, it's just a matter of collecting like terms and solving. 40 minus 30 is 10, is equal to 3y. Divide both sides by 3, y is equal to 10/3. Check your restrictions from the beginning. Is there any reason that that y could not be 10/3?
If it was 0.
Yeah, so 0 is the only restriction, okay? This is not so much fun to check completely because a lot of fractions involved here, but this one does check. Okay, so I'm also going to solve this the other way, right? Where I'm just going to combine the left-hand side so that we have a common denominator and set that equal to 1/4. Let's do that. Up there. Okay, so if I'm only looking at the left side, 10 over 3y minus 5 over 2y is equal to 1 over 4. So again, just looking at the left side, what is the least common denominator?
6y.
6y. So that means I need to multiply this one by 2 over 2 and this one by 3 over 3. So that's going to give me 20 over 6y minus 15 over 6y equal to 1/4. So now I have a common denominator on the left, so I can go ahead and put these into 1. 20 minus 15 is 5 over 6y equal to 1 over 4. And again, what kind of problem do we have now? How would we go about solving this one? Well, do we even need to do that?
Oh,
Well,
since it's 1 over 4, you just multiply the bottom. Yeah.
right.
Cross
Right.
multiply.
It's a cross multiply. Yes, it's just a cross multiply. 6y times 1 is 6y is equal to 5 times 4 is 20. Divide both sides by 6. I get y is equal to 20 over 6, which reduces to 10 over 3. Okay. All right. So you can solve with, why did it do that? Either method. Usually it's quicker to do the thing I showed you first, right? Just clear all the denominators. However, sometimes you have problems where maybe you already have a common denominator, and so it's easier just to combine into one and then cross multiply. All right, so all of them are just slightly different. Okay, ready to look at the next one? Yep. Okay. So this is one of those cases. I already have a common denominator on the left-hand side. So since that's already the same, this one is almost easier to just combine the numerator and put the denominators as 1, right? I can turn this into x plus 2x minus 3 all over x minus 1, which is equal to 2. Okay. Right, and so again, our goal here is to get x by itself. Right now I have x in a denominator. I don't want it there, so I can multiply both sides by x minus 1. That will clear out there, and I'm left with x plus 2x minus 3 equals, and then I'll have to distribute this, 2x minus 2. Right. And so now it's a matter of just collecting our like terms. I see that I have 2x on both sides, so I'm just going to eliminate those, add the 3 to the other side, and I'm left with x equals 1. What's the problem with this solution, though?
X can't be 1.
X can't be 1. All right. So what does that mean for this problem?
No solution.
There's no solution. So again, always be careful and check the original. Okay. I'll go ahead and run through it real quick. The other method of just clearing the denominator, again, the denominator is exactly the same, so we would just multiply both sides by x minus 1. So again, if we had x over x minus 1, and we were multiplying that by x minus 1, plus I had the 2x minus 3 over x minus 1, and again, if we were multiplying this by x minus 1, and then multiplying the other side also by x minus 1, okay, because remember you have to multiply every single term. So again, this would clear, I would have x, this would clear, I would have plus 2x minus 3 equals, the other side would be 2x minus 2, so do we end up getting the exact same thing? Yes?
So in the first one, how did you know, like, the first step was to multiply by x minus 1?
In this one here? Because you're going to look at the least common denominator of the whole equation.
Okay.
Right, and so we only have x minus 1, so that's going to be the least common.
Oh, okay, thank you.
Okay. Let's do this one here. Okay, so this one, I've got this x minus 2 and 3x minus 4. They're both on different sides, so I'm going to go ahead and try to just clear all my denominators by multiplying by the least common for the whole thing. Right? So, again, we have to do the entire side, and we'll do that by x minus 2 and 3x minus 4. And again, all of this side by x minus 2, 3x minus 4. Okay, I'm going to go ahead and write the whole step out so that we see why we are able to simplify this. In the first one, I have 2x times x minus 2 times 3x minus 4 all over x minus 2. And for the next one, I have 1 times x minus 2 times 3x minus 4 all over 3x minus 4. And for the last one, I have 2 times x minus 2 times 3x minus 4. All right, so in the first one, the x minus 2's will divide out, leaving me with 2x and 3x minus 4. In my next one, my 3x minus 4's divide out, leaving me with x minus 2. And the last one, what am I going to have to do with all of those? Multiply everything out. Everything has to be expanded. All right, so I'm going to start by doing 2x minus 4. And then multiply that to the 3x minus 4. Okay, so I've got x's all over the place. some in parentheses, some not. I need to undo all the parentheses by distributing. So this first one here, 6x squared minus 8x equals x minus 2 plus, I get 6x squared here minus 8x minus 12x plus 16. So now I'll start to collect my like terms. And of course, we always love when terms immediately divide out or cancel out. I've got 6x squared on both sides, so if I subtract one from the other, that goes away. Okay, and then let's see. I have a negative 8x here and a negative 12x. So this here is a negative 20x. And I still have a positive x over here. Let me just go ahead and write in the rest of these. Plus 16. Okay, and I still have a negative 8x on this side. All right, so I'm going to add my 20x. Add the 20x and subtract the x. And let me see, minus x. And what am I left with? 12 minus 1, 11x. Equal to, and then I have 16 minus 2 is 14, which then means that x is equal to 14 over 11. Okay. What are the terms or the x values we know we can't have? 2 and 4/3 we know will not work. Okay, 14/11 is not equal to either one of those. But again, we can do a quick check. 2 times 14 over 11 all over 14 over 11. Good fraction practice, yes? Minus, I need a common denominator, so I'll do 22 minus 11 equals 1 over 3 times 14 over 11 minus, again, common denominator, that'll be 44 over 11 plus 2. Okay, not very pretty. I'm not going to work through it all the way. I will tell you, yes, it does indeed work. And so our solution is 11 over 14. Okay, any questions on what we've done? All right, so every one of these really has its own little nuance. So it's not really helpful for me to just keep doing them in front of you. This is better for you guys to just jump in and start practicing them. I've got 6. So I'm going to ask you to work with a partner up on the board to solve these together. And of course, I'll answer any questions you have or come help you if you get stuck somewhere. So here are the rest of the problems worked, the ones you did up on the board, just in case anybody wants to look back. A was r equals 10, B is k equals -2, and C, A equals 5 and -6. On D, x equals 7. E, we have x equals -1 and 4. And F is x equals -2.